All right, so we're going to do this as a chat format. So you're and I are gonna be talking a little bit, and then we'll try to open up to question sort of sooner rather than later in the conversation. So as a quick intro, you are one of the co-creators of Apache Spark, which is a unified framework for building data pipelines, and also one of the most active open source projects in big data. And you are also the co-founder and CEO of Databricks, which is the hosted cloud version of Spark, and a company that I guess in its few months of existence has already raised something like 47 million, I believe, from NEA and Andreessen Horowitz. So amazing ride, and congratulations on all those achievements. So we're going to cover a bunch of different things, but I was curious to maybe start with your story, how you started all of this, as an entrepreneur and then as a professor.
Mm-hmm. Yes, thanks for having me. I got my PhD from Carnegie Mellon University, and then I joined Berkeley 2001 in the spring. And then my research originally was in networking, quality of service. Then I've done some work in peer-to-peer, and then after 6 years, I took a leave from Berkeley and started the first company with my advisor from Carnegie Mellon on it was video distribution. And initially started as a peer-to-peer system, but soon evolved into analytics and control for the video in the internet. So basically, it's providing real-time analytics and also provides a control to optimize the quality of the video of every viewer. And the company today still powers some of the most well-known content providers.
That was Conviva, right?
Conviva. Yes. It's HBO Go, it's MLB and so forth. And the reason I am going there is that there I've seen for the first time some of the challenges with processing large amount of data. So this was around 2007, 2008. So the way we build, the infrastructure for Conviva, it was a backend which got the logs from every client in real time, and both providing real-time analytics and also provide some control to tell every viewer, what is the best bit rate, what is the best source, CDN, content distribution network, to get the data from. So at that point, in big data space, there was Hadoop just started, but of course that was back then. It was mostly batch computation, so you could do historical analysis, but not much more than that. So we ended up building at Conviva, a real-time streaming pipeline, as well as a pretty sophisticated backend to make decisions based on this shared and global state in real time. After 2 years, I went back to Berkeley and started this research in the area of big data. So that was one vector, Conviva, the experience from Conviva. The other vector there are two others. One, at Berkeley, we have this lab. It was called Rad Lab then. And we are side by side with the machine learning people. And the machine learning people, they wanted to learn machine learning at scale and came to us and said, we use Hadoop. And of course, it was very slow, right? Because if you look at Hadoop, if you look at a machine learning, fundamentally it's an iterative algorithm, and every iteration is turned into a Hadoop job. So between the iteration, you write the data and read the data from HDFS, so that's why it's very slow. So that's one. And the other one, we are also have very strong connection with many of these new internet startups. So I remember the first time I visited Facebook, they were still in downtown Palo Alto, and their big data cluster was 80 nodes. And they had their big data team was 3 people. And 2 of newly hired, if I remember correctly, from Yahoo, they were just starting the work on Hive. So it was very early on. So again, this is kind of what is the genesis of what we started to do at Berkeley. And then we started with this first cluster computing framework to resource management, actually. First was a resource management system called Mesos, which the goal was to multiplex a cluster between different cluster computing frameworks, between different instances, maybe different instances of Hadoop or MPI or something like that. And then after that, the next project was Spark. And Spark was, we targeted first some workloads which are not covered by Hadoop. And from all this experience I mentioned earlier, we look at iterative computation to support machine learning, as well as interactive computation, right? Interactive query processing. So
maybe help us understand this. So there's a wide variety of folks here with different levels of understanding of all of this. To the sort of uninitiated, Hadoop was the big thing for the last 2 to 3 years, and then Spark sort of appeared on the scene. Can you maybe help us understand, so this HDFS, which is the storage, and MapReduce, which is the processing, is it correct to think that Spark is basically a better MapReduce or better processing component?
Yeah, that's very good. A very good question. So if you look at the Hadoop stack right now, there are 3 layers. You have the storage layer, which is HDFS. Then you have this kind of resource management layer, it's Yarn, and then you have the engine or a computation layer, which is Hadoop MapReduce. Broadly speaking, Spark fits at this 3rd layer. It's execution engine, parallel execution engine. Okay, and it's working very well in the Hadoop ecosystem, although originally was built to run on top of Mesos. Today is working on Yarn, working standalone, and is working also in addition to HDFS, imports and export data to many other data sources.
Yeah, so perhaps more specifically, can you go through the key advantages of Spark over MapReduce? So in terms of, I think you...
Advantages,
the advantages, the API, the speed.
Yeah, so I think that, the way we look at it, Spark has 3 key advantages over MapReduce, Hadoop MapReduce. One is much faster because it was built from ground up and optimized for in-memory processing. And just to make sure and, to be very clear, Spark is not good only for in-memory processing. It's very good also for processing when the data is out of memory. And if you know, like just October last year, we had we won this kind of Terasort benchmark. And in that benchmark, the data it's not in memory, right? It's SSDs and so forth. So that's number one, the speed. The second one, it has a very powerful and easy to use API. And this fundamentally makes it much easier to write applications. So with Hadoop MapReduce, if you write an application, you need to cast the application into a bunch of maps and reduces, right? Which sometimes is hard. With Spark, you can really almost write arbitrary applications. The API includes, I think right now, over 100 operators, with map and reduce being 2 of them. And the third one, it provides a unified platform, like you mentioned at the beginning, and it goes beyond supporting batch computation. It also supports streaming, interactive query processing, as well as this more sophisticated computation in machine learning, graph-based computations.
And just maybe to build on this, so maybe contrast that with the usual sort of data pipeline and how you need to have ETL and then build all those different components.
So the key here, one way to look at Spark is that think about that you have the ability to run a highly parallel job instead of tens of minutes or in less than 1 second. Okay, so that's your fundamental construct. So if you have that construct and you have a powerful API, you can do almost anything, okay? And also to that, you add the ability to share the data between different, this kind of, for different, highly parallel operators, you can share the data between them in memory, right? So now, it's again, if you have that, of course you can do batch, right? Because you just, a longer job, right? Or a longer, you can do streaming. Because why you can do streaming? Because you can emulate streaming like a sequence of micro batches, right? The new data comes in, you look at the new data, maybe the past second, and you update whatever you are computing, and you do this incremental update every second or every hundreds of milliseconds. You can do interactive queries because you can now run jobs in less than 1 second. And like I mentioned, if you look at graph computation, machine learning computation, it's supporting them is about efficiently support iterative algorithms. And each iteration is very fast. Between iteration, you share the data in memory, and here you are. You can address that. And now you have a platform that can support this all the workloads and gives you tremendous benefits. Because if you look at the alternatives, what you are going to do, you want streaming, you are going to do Storm. Okay, you want batch, of course, Hadoop is still a very great batch engine. You want interactive query processing, Impala, maybe Drill, and you want graph computation, maybe GraphLab, Giraffe, machine learning, Mahout, and so forth. But then you are stuck with a lot of systems, and if you want to provide, to build your end-to-end data pipeline, you need to stitch them together and integrate them, and this is pretty hard. While with Spark, you can use only one engine and only one API to support all these workloads.
And to take just one of the things you mentioned, so maybe contrast Spark streaming with Storm, which also does micro batching.
Well, actually, Storm is a more classic streaming.
Yeah, I mean they come from different places, but
they come from different places, and Storm is more traditional streaming engine. Look, I mean, the big advantage, I think, you can run the experiments whenever you run, you can run benchmarks, or, based on the benchmark and on the workload, you may get different results. They are roughly, in terms of the throughput, they are roughly similar. But what Spark provides you, because it's these micro batches, it provides you exactly one semantics. So it guarantees that each record is processed exactly once. The other thing it provides is a fault tolerance. You have out of the box. The nice thing about batching, it's fault tolerant, right? It's basically you have a failure, you re-execute and recompute the result. So by using this micro batching paradigm, you get all of this for free, right? So as long as you can do this very fast, there are a lot of advantages. So I think the one disadvantage you get, you inherit from these micro batches, is that it's very hard to, if you want millisecond latency from the time the data entered in the system until you get the result, is very hard to get. You can get latencies of several hundreds of milliseconds, but milliseconds, very hard. And so, for instance, what I can say is that Spark streaming is not, the best solution if you look for financial trading, right? So that's a trade-off.
Okay, great. Let's switch gears a bit and talk about Databricks for a minute, and then I'll open up for questions. So, what does the cloud platform, do?
Yeah. So, Databricks, and I hope that many of you will attend tomorrow's Spark Summit.
Where is it?
Spark Summit.
Where is it?
It's just in Sheraton. It's here in New York. It's the first time.
At the Sheraton. Okay.
Sheraton.
Okay.
So look, the main goal as a vision of Databricks is to make the big data easy, right? It's very hard to do big data, and for various reasons. You need to deal with various tools. You need to assemble them to create a pipeline. Before that, you need to set up a cluster. Once you set up the pipeline, even then, the tools are pretty hard to use. So really, the goal of Databricks Cloud is to make this much easier. And the way it's doing it is providing a hosted service. Today, we run in Amazon, AWS. And it has a few things to make it easy in addition to Spark. So it provides a cluster management system, which allows you to really spin off clusters, steer them down in seconds, scale them up and down. It's very easy for multiple users to share the same cluster and things like that. And in addition to that, it also provides a workspace. So this is basically a set of tools. It has notebooks, dashboards, and jobs, which makes it really much easier and faster to process the data, all the way from ingestion, data transformation, interactive exploration, getting insights, and then productizing these insights, having data products, and running them at scale in production.
Great. And maybe one last question from me. What is the relationship between Databricks and the Spark community specifically? What percentage of the contribution do you think are produced by Databricks as opposed to the rest of the community?
Yeah, so right now we have a great community where we exceeded 500 contributors. It is the most active big data project right now, Spark. And a lot of contributions. Still, the majority of contribution comes from Databricks. And from the Databricks, it's as a strategy, it's a two-step strategy. Like first step, just to be very clear, we want Apache Spark to be highly successful. And everyone to use it. The more people use it, the more potential customers we have for Databricks Cloud. We don't have our own distribution. We provide only the service. And therefore, we collaborate with everyone, and we help everyone who wants to distribute Spark. Also, we try pretty hard in order to fuel the growth of the ecosystem. So we have certification programs, both for the application and for the distribution. So therefore, every certified application will run on any certified Spark distribution. This is also will alleviate the risk of fragmentation. Really we do a lot of work and we spend a lot of resources for making Apache Spark successful.
Great, thank you very much.
And by the way, one thing I want to mention is that Databricks Cloud, to this point, it's an open platform. So actually, if you wish, you can take the code you develop in Databricks Cloud and run on a certified Spark distribution. So it's not really, you are not locked in.
Okay, great. Questions? I think, not to put him on the spot, but my friend Justin had some questions. It's over there.
Hi, I was going to ask about secondary indexes or global secondary indexes. So I know everything's in memory and that makes things pretty fast, but there's still some use cases.
Can you speak a little bit louder?
Oh yeah, sure. There's still some use cases where it would be great to have secondary indexes. So like RAM Cloud just added them. Some of the other in-memory things add them. I just wanted to get your thought on that and whether you guys were considering that for Spark.
So you're asking about more use cases or?
Secondary indexes.
Yeah.
Secondary indexes.
Secondary indexes and so forth. That's a good question. So, there are research projects to add these secondary indexes. Actually, there is a related project at Berkeley. It's called Succinct, which actually go even more than, beyond that. It's a project that allows you to, allow you to have, query processing on the compressed data. And so you don't need to uncompress the data in order to search on that data. And that gives you, you can do arbitrary string, substring matching. So really this can help you, it's equivalent of almost, if you have semi-structured data or structured data, it's equivalent to having an index on every column. But we expect that to see in Spark over the next couple of months, at least some of these technologies. Not succinct, but at least indexed RDDs and so forth sooner.
Great. Any other questions? Do you want to take another one, Justin? You've officially been appointed Spark questionnaire in chief.
Yeah, sure. Let me think. Okay, so another one. So I know that the use case for Spark is not necessarily like data warehouse-like workloads, right? But there's been a lot of investment in optimizing Spark SQL, and I think a lot of the use cases that people in practice actually use it for are SQL-like workloads. So I'm just kind of wondering where you see this fitting in this kind of big data stack where you have multiple systems. Do you honestly see Spark as being like the only system, or kind of existing alongside an actual data warehouse for SQL-like workloads?
Yeah,
and that's kind of a loaded question, but
it's a good question. So look, at the end of the day, Spark is an open platform, and like I mentioned, it imports and exports data from a variety of data storage and distributed file systems, so you can use side by side whatever tools and systems you want. There is no question about that. Now, I do think that looking forward, you are going to see more and more of this unification. This happens in many other industries and technologies. I do think this will happen in big data because it's so much easier if you have only one system than if you need to deal with many. And it's not only about operationally and so forth, but think about the fact that you need to train people only for one system, one API, one programming environment. You don't need to have, Clojure for Storm and Java for Spark and so forth, right? So I think that will go towards that direction. Now, regarding Spark SQL, this is one of the main focuses, at least also at Databricks and in the community. And right now, the most of the effort of providing functionality. It's in terms of the parser, it's a Hive parser, and recently we also released this data frames API. Which is very similar with the pandas, which is very popular. And the key things about Spark SQL, and one of the main advantages, maybe it's not the fastest right now, is the fact that it's a unification. On these data frames or it's schema data, you can share with all the other components of Spark and libraries. You can call, for instance, machine learning. You don't need to move data around. It's the same. You call it on the same data objects. Another thing, let me give you another example. So say, and this shows you the power of unification. Say you want to do interactive queries on the streaming data. How do you do it today? Well, you have Storm because it's streaming data, and now you may want to run queries. You need to write queries in the Storm like a job. It's pretty complicated, and it's not going to scale very well. Or you take the data out of Storm through maybe HDFS and push it in Impala, right? But then it's not real. The latency is pretty high. So because you have unification in the case of Spark, well, you get the data from for Spark streaming, and immediately on the same, you don't need to copy, on the same data objects, you are going to, you can run Spark SQL. Okay? So these are the advantages. So now going forward, we are looking forward to increase and improve significantly the performance, and we are working on that quite a bit.
All right. One last, can we keep it just to 1 minute question? Shot.
Oh, since the microphone's already here. Real quick, I just heard an investor refer to Databricks as the SaaS killer. I was wondering if you could give any comments on that. Like, is that who you guys really see in the existing, lots of business users here, field as a direct competitor? Like, is SaaS the end game to replace them? Just curious.
Well, the answer should be yes, right? Look, we are a startup, so we have a little bit over 50 people, so we need to focus, right? So that's our, at least the first product, and we are looking. It seems that we see more and more companies moving on the cloud. And for the foreseeable future, it looks like it's a good size market. If you hear, if you listen to Amazon, they tell you that they have 1 million customers on AWS, and guess what? Many of these customers, they do have data. They collect data. So it seems, we'll see. But, it's so much easier. Everything is so much easier, right? It's easier for the customers. It's easier for us. We can speed up the development much faster to fix any problems and share the data sets and all of this stuff. It's, you get all these advantages. But it's the fact that you have the data gravity. The data gravity, yes, if the data is on-premise, it's hard to go on the cloud. But if the data is in cloud, you have an additional advantage because that data can actually be shared, of course, with the proper rules and ACLs between not only within your own organization, but between, different customers.
Terrific. Well, thank you very much for being here and sharing all of this with us. Thank you.
Thank you.